Okay, so the lesson number 3, these are three tasks: 3.1, 3.2, 3.3, and the first one is keeping the equations true. So you can see which are the solution to x times x equals 5. Okay, so the question is, can this be true? Why this is not correct? You can see if I plug in here, what do you get? It is 1 over 25 times 1 over 25. Can it be ever be equal to 5? Is this true? Possible? No, correct? Because this is going to be like a 1 over 625. And how can you say it is equal to 5? This is wrong. Agree? So we can say, okay, that's not correct. So that means the first one is not correct. What about the second one? Is the second one right? Okay, let's put this as x. So if I put this as x here, and you can see if I put square root of 5, square root of 5, do you think agree? Yes, correct? Because square root, when you have square root of 5, the whole square is 5. And why? What is the reason? Because if we have this raised to square, the answer is straight away cross out because they are inverse of each other, and you get the so is b. So this is like a formula where square root of b times square root of b is always b. That's it. Always correct? Agree? So that's why this is correct. And even if there was a minus root 5, let's see if there was a square root of 5, this also could be the correct because you can write square root of this times square root again, and then this also gives you 5. Okay, so it's multiplying. So it's like square root of 5. When you write like this equals 2 negative makes it positive, and square root of and square root cross out, and we end up getting 5. So that's correct. So these are just kind of explanation why it is right. So do you think the C is correct? What about C? So see, if I this is 5 over 2 times 5 over 2, you end up getting 25 over 4. But this is not 5. So this is wrong. First one also we got wrong. What about this one? D. Do you agree, D? And you can see many of you may be asking why this is correct. And you can see if I multiply itself, the same thing 5 raised to half and 5 raised to half. You can see here. And what do you use the laws of exponents? And the laws of exponents says you can write the base only once, the 5, and then add the exponents. And we do know what is half plus half is 1, which is 5. So you end up getting the same 5. So what does it mean is that this is the solution. That means this is correct solution. Agree? Okay. So I'm just going a little slow so that all of you understand and try to do. Okay. Very nice. If you understand step by step, it's really nice. What about this part? See this. Now, if I write multiply itself 2 times, let's see if I want to multiply this, what do you end up getting? So if you do this is square root of 5, multiply square root of 5 in the numerator, and 2 in the denominator. But we do know these two pieces, square root of 5 and square root of 5, is 5, and down is 4. So this if it is not same as 5, and that's why this cannot be the answer. So the only choices that you end up getting is the B and the D. How many of you got this answer? Thumbs up. So many of you did not get, and I hope at least now you know these are the only two answers. Okay. Now to check whether is this the solution for x times x is 5, you can see you can plug it in here and this is square root of 25, and this When you multiply this to itself, it is 25. Okay? But you can't say 25 is equal to 5 here. So they are not the same. This is false. So in other words, you also know square root of 25 is 5, right? Because 5 times 5 is 25. So naturally, this is false. So this cannot be the answer. So that takes care of the 3.1a. And now let's go to 3.1b. Okay, this question says select all the solutions to this one. Now, what does this means? P time, when you write P times P is 10. In other words, you are saying P multiplied itself 3 times, which means P cube is 10. So what is that number? So what is this P that multiply itself 3 times to get to the 10? So that's the goal, right? Now let's see whether the first one is correct. So what I'll do is the best way to check is multiply itself and see what's going on. And remember, this by definition itself, this is by definition. Let me write definition, by definition, when you have this, p cube is 10, p is cube root of 10. There, you already got the answer right here. Look at this. So this is the answer you get straight away here. So it basically means cube root 10 times cube root 10 times cube root 10 is 10. That's all it means, even though it looks a little creepy, but that's what it is. So it is cube root 10 3 times what it is, whatever the radical inside, the 10 which you see inside. So that's the answer there, okay? So first of all, E is correct. I think Brianna, you got it. E correct? Okay. Then the question is, many of you may be thinking, hey, why A is correct? Why is this piece correct? Even though the definitions, not definition, it is seen that uh, 10 raised to 1 over 3 also is correct. So this, and it's because this thing, this p which you see right here is same as writing 10 raised to 1 over 3. So all this looks little creepy. I always say this, but then we need to really confirm, is it really true? And you can see 10 raised to 1/3 times 10 raised to 1/3. So if you do this 3 times 10 raised to 1/3, okay, see how it is? So when you multiply itself 10 raised to 1/3, what it means is you write the base only once, and then the exponents are added, okay? And 3/1/3, when you make a whole circle, I can break this into 3 pieces, like see. So each one is 1/3, 1/3, and 1/3. And together they make up the whole around, the whole, right? 1. So that means this is 10 raised to 1. And 10 raised to 1 is 10, see? Which is right here. So this is at 10. So that means the P, in this case, this also is P. So this is P, P, P. Is P. So that means, and here we have, so this is like P, P, and P. So that means this is P, correct. So that's the answer. So P equals 10 raised to 1/3 is also correct. Is that agree? Everybody agrees? Estras? Ashley, you taking a note? Okay, so a lot of writing work there, but the goal is just to understand this why it works. Okay, and you can see B, if I want to know why cannot be the answer. So the question is why this is wrong, because if I multiply this itself uh, 3 times, so if I multiply this itself 3 times, the first two will give you, look at this, this two will give just a 10. This is 10 because square root of B is B. So that gives you 10, and there's the square root of 10. But remember, you're supposed to get 10, and here you got 10 root 2, and they are not the same. So this is wrong. So I hope you guys agree with that. So little kind of understanding I write this. So if you miss anything, you can always check on the video there. So this one, is this correct? Let's see if I multiply 10 over 3 times 10 over 3 over. Now this helps us to really understand the concept of cube root. Okay, that's why I write this again and again. This piece. What number multiply itself 3 times to get to 10? That's the question. What number? Because later on that you're going to think of logarithm. There's one lesson on logarithm where uh, what number multiply itself 3 times 8, and we get an inverse function called a logarithmic function. Now, in order for that lesson to be easy, you need to know this exponential function. Okay, so this piece is, if you see this you end up getting 10, 10, and 10, and the down will be 3 times 3 times 3. So that way you get 10, 10, 10 is 1000, and 3 times 3 times 3 is 27. Okay, you can check it out. So if you see 3 times 3 times 3, this 2 is 9, so 9 times 3, and 9 times 3 is 27. And you can clearly see this is not equal to 10. So this cannot be the answer. And likewise, you can check all of them. And you see this also cannot be, this is right, and this is cannot. And you can, okay, this is activity 3.2. Everybody, let's make a table to understand, get a hang of. Everybody make a table like this. So quickly make a table. And in Florida in 1800, that is in 1840, the population of Florida city, that's in population of Florida, the state, right, is 54,000. So let's put it like this, 54,000. So this is 54,500. So that's like a zero here. So I'll put a zero here. Okay. And this is 1840. So right on top, just to understand the concept, I'm writing 1840 is the population was measured. And between 1840 to 1860, let's see. So this is 1860. Population grew exponentially. So 1860, that means it's like 20 years, but they try to break this into 18, so 1840, sorry, let me write it 1850. So this will be 1850. Okay. And I'll write 1860 here. Okay. So can I see everybody writing the thing? Make a table that just to get a hang of this. It means, so this is represents D. D represents number of decades. And this is the population. So it's represented by f of D. So you have to understand the function notation. What is this f of D? So fd is the population in the state of Florida. Population of Florida, D decades. So the meaning of this is to be understood. D decades since 1840. Is that correct? So 1840 is the beginning where the population was 54,000. And you will see uh, this is actual 1 year. Okay, this is like a year, 1 year. So this means 1 decade. So that's the important concept here. So this is a zero. This is zero. This is one. X is 1 here. D is 1 here. This is 2. So far, so good. Okay. Now the question is, what is the population? So find the population in Florida in 1850 and in 1860 according to this model. So how do you figure that out? The only so they did give us the person increasing. The population is growing exponentially by 60%. Now, what is 60%? Okay, to figure out the population in the year in 1 decade, that's in 1850. So we'll write down. So to figure out, we need to understand again. I write 60%. Now, what is 60%? Is 60% is percent increase in the population every decade, which is 60 divided by 100, and that is 0.06. You can check on the calculator also. So 0.06, but then we need to know the growth factor. So what is this growth factor? The growth factor is the B part. And the B is, we write 1 plus R. So B is, this is the R, which is percent increase, that is 1 plus 0. I think I made a mistake here. This should be zero point 0.6. This is 0.6, which is the percent increase, right? So this becomes zero point 0.6, and the growth factor becomes 1.6. So this is important number. So when you want to figure out 1850, how much is the population, that means uh, the question second says the population is a function of number of decades. Write an equation. I think this should have been the first question, but they try to check on students' understanding whether we can find. So here I will write down because FD represents, so let's see, FD represents, let's write a formula first so that now that we already know. So in the beginning, so it is A times B raised to X. This is like a formula, but now in the beginning, the population is 54,500. And then the B part, that is the B is right here, that this is the B. B is 1.6. Okay, so that B goes right here, 1.6, and then raised to the X. Now, X here we are using is D, the number of decades. So 1840 to this piece is 1 year. So you need to put 1 up here. Okay? And on your calculator, if you multiply these two, you end up getting 8, 7, 200. Did you get this? Thumbs up who got this? 8, 7, 200. Okay. So check this, that when you multiply these two pieces, 54,500, so the answer becomes 8, 7. Okay. So that's like 60% increase in the population from 54,500. Then the second question is from here, you want to know what happens. So you can either multiply one more time 1.6. That's like, so again, let me show this right here. So you're multiplying from this number by growth factor. So this is multiplied by growth factor 1.6. Then again you multiply 1.6. So there are two ways you can do. One way is directly multiply 18 population of 1850. Okay. So this piece. So if I want to know what is this one, uh, so that means even though this piece I should have written here f of 1 because the decade is 1 decade until 1850 is 1 decade. But if I want to know from here to here, there are 2 decades. See this? So two ways to do. One is just multiply this numbers 87200. If you multiply by 1.6, you get, or you can also do from the beginning. So 54,500 is what you had in the beginning, and then you multiply 1.6 times 1.6. So multiplying 1.6, 1.6 itself, and you end up getting, check the answer, what you get. So do you get 1,339,520? Yes or no? Oh no, I should write it here. Other. So 139, is this correct? So how? So there are two ways. Either you write this way, you start from the beginning. If you can write from the beginning, but you are multiplying 1.6, 1.6 twice. It's like, let me write it one more time here. So it is 54500 times 1.6, which is the growth factor. This is raised to the power 2. Got it? Right? So it's like raised to the power 2, which is actually f of 2. It is f of 2. It means 2 decades since 1840. So does it make sense to you? So the answer is 139520. So both answers give you the same thing. So we can now conclude. So we can make a conclusion out of this that every time, let's see if I want to figure out the next decade. Let's see, I break this and I want to write the next decade. It will be 1870. We can easily use 1 point. So it's like from here, one more 1.6 will be multiplied. So altogether, from this, if I want to find here, and you can see there is 1.6, 1.6, sorry, 1.6, and another 1.6. So there will be three of them, 1.6 raised to 3, and eventually you get like a exponential function. That's the question number 2. So we write f of d, d equals, so I'll use the d for the important number. Then blue is what you had the population in the beginning times the B, that is the growth factor is red. I'll put 1.6 and raise to the power D. And this is the most important formula. Got it now? So many students get confused as, hey, where does this come from? And you can see how it works. It's just every 10 years, you are figuring out the population of the Florida state. And you know where Florida is, right? On the eastern side. Atlantic Ocean is closed that side. Okay, so that takes care of this one. But what does this means? Look at the next question is, let's now move on, okay? So the next question is, explain what f of 0.5 means in this situation. Anybody would like to share? So in this case, d is 0.5. What is 0.5 means? Half, right? So it is like half, right? Otherwise, it is also means half of a decade, right? Half a decade is also half. So half of a decade, right? So it also means how many years? A decade goes how many years? 10. So if I say half of decade is, make sense? So little understanding that what does that basically means. So what is 0.5? You have to write, oh, it is 0.5, which is half of a decade, which is 5 years. That's it. Now, if they did not ask us, oh, they're asking us to graph this. Okay, now let's see. We'll have to go to desmos.com and really graph. Okay, so can you open your laptop? Everybody open your laptops and let's check this out and see if we can get this answer. So we need to know, remember the graph, as you guys are working on this, I'll just get ready for this. The population in the beginning is, and we did 2 decades, one and two, and the population went from, let's see, this is 50,000, then 100,000, then 150,000, then 200,000. This is 150,000. This is 100,000. This is 50,000. So in the beginning, the population was, now instead of writing this big numbers, we can still write it as like uh, using the, just using, let's say this is 50, this is 100, this is 150, 200, and like this. And 54 will be somewhere. So this is just to estimate, okay? It's not a perfect. So in the beginning, the population is 54,000. So 54,000 will mean like this too. And the one that we got two answers is, sorry, this was 54,000. The next one was 87, maybe here. And of course, I'm just trying to show with a sketch, but that's not going to be good on 139, somewhere here, maybe here. So the population is growing something like this. It's just going this way. But then let's go to the desmos.com. So let's use open desmos.com. Did you do? So click on the calculator. And here let's put the equation as FD with f of d equals, so 54,000 times times 1.6, and then raised to the power d. Okay, so we want to put this equation in Desmos. You see, you can't see this because of we need to have a 54,000. So there's a 54,000. So we have to change this. This whole thing we have to change. You can zoom out also. See, you see this. It doesn't look like, so we have to go to setting, go to the setting. Let's change this to 0 to, take this off. I'll put -1 there. Okay. And here we'll put 5 years, 5 decades. Let's do 5 decades. And in the y we'll put -10 -5,000. And the right side we'll try to make it 200,000. But our numbers is 139, so I'll make maybe 200,000. So the question is, what was the, did you get what I'm saying? So you have to get used to this. Question is, why did I pick -1, right? You want to see little off to the left side of the y-axis. And I try to use 5 decades. Okay. You can put 6 also. You can put 4 also. Okay. If you put more, is always better. You get that shrinks. But if you put 3, see, it looks more beautiful. But I'll use 5. 5 decades, 50 years. And why did I pick -5,000? It's because we want to have something below the x-axis. And you may say, why not 10,000? Yeah, you can put -10,000 also, because the output which I picked is 200,000 there, so that we know even 2.5 what's going on there. So one way to figure out approximately. So on your paper, we need to approximate. How do we approximate? Now, where is 0.5? So hope everybody got this graph. This looks more beautiful even if you put 250,000. See, if I put 200, it looks more better also. See, uh, so the question is 0.5 we need to know. So use your use tracing. We'll try to use this to see this tracing. We want to know for 0.5. So where is 0.5? So right here, so 0. There I'm trying my best. So check that 0.949. There you go. Did you get the answer 0.5? So what is the answer? 68,000, 68,305, right? So that's like approximately, right? It's not a perfect answer. Remember, this is not perfect answer. Okay. So on your paper, can you write down the answer approximately, whatever they asked? So it says explain that we did A. B is graph your function using an estimate, and that's the estimate 68,305. Okay. But if I want to really find the exact one, and this is what you do. So over here, next, here you write down D equals 0.5, but it doesn't accept because of the software will put X equals 0.5. Can you click it? So on the second row here below FD, so there you go 0.5, and you can see, I think I messed up a little bit here. The actual is 54,000. The original population was 54,500, I think, right? And I messed up there. So please, if this was missing, so halfway down is like this. 0.5. So that's 68,937 is the approximate. But if you really want to know exact, then you have to draw the vertical line like this, and you get the answer. Can you see? So it's 68,937. So that's the actual population there. You see the question number C, they're asking you explain why we can find this by just multiplying this by this. Now what this means is, remember FD was 54,500 multiplied by 1.6 raised to D. Now because the D is half, so this is half. So I'm going to use half. This is half, correct? And we know by that is same as writing 54,500. And this is same as square root of 1.6, which we have already seen in the first uh, 3.1 there, right? So so b raised to half is same as square root of b. So that's why it's as good as multiplying this and getting the answer. So the question was asking, hey, can you explain why this is say how this is same as multiplying 54,000 by this is because of these two things mean the same thing. Look, and I hope that takes care of that question. And then based on the model, what was the population of Florida in 1858? Now remember, I remember showing this way. This is 0. This was 54,000 here. Okay. Then I kept a space room here, and then I wrote 1840. Then I wrote 1850. Then I kept a room for me, and then I wrote 1860. Okay. So the question is asking, show your reasoning. So how do you, what was the population in 1858? Now, where is 1858? So this is 1840, this is 18, in between I can see there are, I can mark 5, 10 years there. So this is what I wanted to show. Look at this. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 like this. So there are 10 years in between. And the question is asked 1858. And maybe this is the one. Let me take this off. So in between here, this is the piece that I see here. This one is 1860, right? So 1858 will be this one. Bless me. So that's 1858. See? So that means, what is D there? Can somebody tell me what is D here? So this is the D, this is the FD. So if this is 0 and if this is 1, what is this number here? How do we figure that out? Because this is 2, right? 2 decades. Then you have 3 decades, but in between something is happening. What is that? So how many decades is from 1840 to 1858 is how many decades? Starting from 1840, all the way you go to 1850. How many decades is it? From here to here, at least is 1 decade, agree? And from there to here, how many years are here? 50 to 58, how many years? 8 years? So how do I write? What is that D then? Okay. So the right way, if you get confused, is 1858 and the beginning is 1840. How many years if I subtract? 18 years? Nobody is saying yes. Correct? Now 18 years we can convert it to, so 18 years we have to convert to decades. How do you do this? Because 1 decade is how many years? 10. See, 10 years. So just wanted to show. So this years crosses out and you end up getting 18 divided by 10 and the answer is in decades, which is 1.8. Do you see that? Right? So 1.8 is the question was show your reasoning. So you're showing your reasoning to these are the reasonings. You do this work. Of course, common sense tells you it has to be 1.8. So somehow you should be getting quick answer, but if you get confused, this is how the reasoning works. So if I want to figure out actual population, so all we do is f of 1.8 equals, so 54,500 was the original, and you multiply it by 1.6 and raised to the power 1.8, and you get the answer. I think I have the answer with me, but you can check to confirm. You're going to get 127,000 in this. So that's how it helps to, first of all, you have to model into a mathematical exponential function and understanding what. decades means what? And also in between, suppose they give you some years, you should convert it into decades. Is that right? Agree? Okay, we go to the last activity, and that is 3.3. This is about disappearing medicine. You can see the amount of medicine in the bloodstream of a patient decreases roughly exponentially. You can clearly see the graph is going down, see, exponentially. And here is the graph representing the F graph that models medicine in the body of a patient T hours after injection is given. So the shot is given by the nurses in the hospital maybe, and in the beginning, how many milligrams of medicine is there is showing up. So I'm going to make it a little bigger to understand this. And by just looking at it, look at this. In the beginning, how much, what amount of medicine was given in the beginning? So if you see this, in the beginning, the medicine that was given was is 12, right? Can you see this 12 there? So the first question is, so the graph shows this number means in the, look at this point, 0 is 12. That's the milligram in the beginning. So this is in the beginning. So, and I want you to write a little kind of a table to understand this. Everybody make a table right here. Can you make a table here? So that means this is, so T represents the number of hours. So this means the number of hours. And this one is f of t. So what is ft represents the amount of medicine. So what is ft is amount of medicine. And I'll just finish this rep. Uh, Please allow me to complete this. So amount of medicine in the beginning it was 0, it was 12 milligram. And after 1 hour, that means this is 1, this is 1 hour, this is in the beginning. It is given as 0.075. Okay. The question is asked, use the graph to estimate. Now, what is this f of 1/3? So, what is the meaning of 1/3? Now, 1/3 of 1 hour, right? 1/3 of 1 hour. Actually, 1 hour has got 60 minutes. If you right, and 1 hour has 60 minutes, and 1/3 of 60 is 20 minutes. So 20, 20, 20 make up 1. So that means what you see here is this is like this one, every 4, like let's say this piece is like 5, 5, 5. This is like 20 minutes, like, okay. Then again, another 4 is 40 minutes. So you have to estimate how much is this piece. See this piece? So this is the answer, which is almost little lower here, which is, so it is 1/3. The answer is 0. Maybe 4. So I'm going to write this at 0.4. So I hope we'll continue this. I'm going to make this video completed. Okay, so what I try to do is I zoomed in here. So the question was asked. So from the time the medicine was given, that is 12 milligram, then it in 1 hour. So this is 1 hour, which is 60 minutes. And the question was asked. So the first question was asked, use the graph to estimate. So you're supposed to estimate what is the f of 1/3, right? 1/3. Now if you see in this case, you count here, the spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 spaces is like 1 hour. That means 12, if I divide into 3, gives you 4 spaces. So every 4 spaces, so this is, and then again, this is like 1/3. That's like this piece, this is 1/3. And then again another this will be 2/3. Now what does this means? If I divide 60 minutes divide by 3, it's like 20 minutes. That means this is like 20 minutes, this is 40 minutes, and then this is 60 minutes. This is 60 minutes. So the question is, how much is the estimate? So all you go is all at 1/3. So at 1/3, you go all the way up this, and then there you go. So almost this is what the answer is, and that is almost 1. This is 1. This is 2. This is 3. This is 4, almost 4.8. I'll just write down the so 4.8 milligram. So that's the estimate. This is question number 1. And the second question is, uh, after 1 hour, 0.75 milligram of medicine remains in the bloodstream. Find an equation that defines. So now we need to know this graph that you see. We need to model a exponential function. So how do we model exponential function? So this one, we have to see what is there in the beginning. Okay, the formula to model the exponential function is y is a times b raised to x. That means y represents, which is f of t, because t hours, how much is the medicine in the bloodstream. So in the beginning, so this is 0 and a. That means in the beginning, there was 12 milligrams, and after that, we need to know x. Now this x is t, the number of hours. But what does b represent? And the b is the, here it will be a decay factor, because you can see the graph is decreasing. The b is decay factor. We need to know how much is that. Now this decay factor is, and this is what you have, 1. After 1 hour, it is 0.75. We can easily divide. So in other words, what number? So 12 multiply what equals 0.75. You can see this is the same as dividing. That means whatever you need to know what is that. So that's 0.75 divided by 12. And if you use the calculators, you end up getting 0.0625. So the growth decay factor becomes 0.0625. So that's what you replace this. This is what you get, and you're done. And check check this out. So if you see 0.625 is almost this 0.625 is 0.0625. And how did we get? It is right here, right? Which we can also write it as 3/4, because 0.75 is 3/4, and this is 12. Keep change flip. You can use that, and you get, so 4. So there are 2 4s, so 1 over 4, 16. And that 16 is half raised to 4. So that means this is time. This piece that you see is like half raised to 4, and this is t. Or I'll just use the, instead of directly, we can write this as half raised to uh, so 1 over 16. So it is 16. So another way to check this out also, what does that basically means? 1 over 16 is 1 over 16 is also same as writing 0.0625 point times it's half raised to 4, and this whole thing is, so t equals 1. Let's see, if t equals 1, So I can break this because there were 12 spaces here, and because there is a 16 here. So 12 spaces divided by 4 gives you 3. So every 3 will be, so this is 3 spaces, another 3 spaces, another 3 spaces, and this. So that means half is multiplied. So there is half, 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 half. Because so all the way to get to this, so half is multiply itself raised to 4, and which is, so half raised to 4 is, so that means from here, this is becomes half, right? So that means in 15 minutes now, if you see this is 15 minutes, another 15 minutes, another 15 minutes. So every 15 minutes, uh, so this is 3 spaces. So every 15 minutes, you can see 15 minutes, 15 minutes, 15, 50% goes down. This is half of whatever the 12 here. Okay, I think I made a mistake here. This is 12, this is 12. I just want to make sure we have the right thing here. So that is 12, 12. Okay. So every 3 spaces is 15 minutes. That means what does this basically means? So uh, every 15 minutes, so half of the original medicine given will remain. So that means it is half is 50%. So that means 50% is lost and 50% is what remaining in the bloodstream every half an hour like this. So another question asked here is, are you ready for more? By what percentage does the amount of medicine in the body decay every 10 minutes? So let's go back to the graph. So since the question is asked every 10 minutes, and if this is a clock, and so this is starting, then every 10, this will be 10 minutes. This is 1 10 minutes. Then you go another 2 10 minutes. You have 3 10 minutes. Okay. Then there will be 4 10 minutes. And then you have 5 10 minutes. And then you have 6 10 minutes. So back to, so there are a group of 1 2 3 4 5 and uh, 5 and 6 10 minutes. And you can see this spacing is already 12. So every 2 space will be like 10 minutes. So this is 10 minutes. This is 20 minutes. This will be 30 minutes. This will be 40 minutes. And this is 50 minutes. And this is 60 minutes, which is 1 hour. So the question is, what percentage is going for every 10? So we need to know the breakdown here. So how do we find from 12, what's the percentage it goes down here by what percent? How do we figure that out? And you can see from here 1, 2, 3, 4, 5, 6. So when you multiply 6, so we want to know what is that B which multiply itself 6 times. So let's see, we don't know. Let's imagine if this, I'll put it like a capital B, uppercase B, and we want to know this. So what is this multiplying itself 3 times to get to 0.7. So 0.75. So the original one is, sorry, to get to 1 over 16. So this is 1 over 16. And we've seen this from here to here, this 0.7, and before it was 12. And remember, we already worked it out. 0.75 divided by 12 is, of course, even though it is 0.0625, it is also 1 over 16. And I showed you in the earlier how it is. So this is how many b's? 6 b's. So you have 6 of this. B raised to 6 is 1 over 16. And therefore, we can write this as b raised to 1 over 16 and the whole raised to 1/6. It's like if I have b square is, let's see, any number 14, we write b is square root of 14. If I write b cube is maybe 20, b is cube root of 20, which is also 14 raised to half, or this is 20 raised to 1/3. And likewise, we have this thing where if b raised to 6 is 1 over 16, then this is the growth factor. This is the decay factor. This is the decay factor every 10 minutes. Okay, and then we want to know what percentage is. If you put on this in the calculator, you put this in the calculator, you end up getting 0.63, and this means it is 63 divided by 100, which is 63%. That means every 10 minutes 63% retains, stays. That means you're losing. So what that means is 63% stays, retains means almost like 77%. How did you get that? Is 100% take away 63%, you get 77% is uh sorry, 27%, right? I'm sorry, 100%, 33%. So you have 33%, I mean 37% is lost. So that much of medicine goes away every 10 minutes. But remember the last time I showed every 15 minutes it was 50%. So I hope it makes sense, and the rest you have to do it by yourself. So the practice problem is, I have a separate video, you can check it out. Practice problem. And if you see the practice problem, lesson number 3 and 4 is clubbed together. So this packet, 3 is the one you have to complete, and we'll continue in the next class.